All right, guys, so I just wanted to talk you through the key for the Valentine's Day worksheet. All right, so as you've read, we have two different options for purchasing flowers for a fundraiser. Roses Are Red offers to sell its roses for $20 and then an additional charge of 75 cents per rose. Flower Power charges $60 up front and an additional charge of 50 cents per rose. All right, so the first question is, which company would you choose? Explain your reasoning. This is completely up to you. You can decide which one you'd rather choose. I know a lot of people said, well, I like Roses Are Red because it's a cheaper down payment. Okay? All right, so next we go on and we read. It says, from the description of the two offers, complete the chart below to find an algebraic rule that will determine the cost of N roses. So we start with the process for Roses Are Red. We know that we're going to have to pay 20 no matter what, right? And then we're going to have to add on, it was 0.75 for each of 10 roses. All right, and so when we do that, we should get $27.50. All right, and so then we're going to do the same thing. So we'll do 75 cents for each of 20 roses, and then we'll add on the extra 20 at the end, which this time will be $35. All right. Now, from here, we're going to continue on, and I'm just going to pause it and finish up this row. All right, so we got them all filled out. We've got the process column. We've got the costs all filled out. Nice, nice. Now, this last one asks us to do N number of roses. Now, don't freak out because it says N. The whole point of this, remember, is that we're trying to create an algebraic rule that allows us to find the cost of any number of roses. Well, if you look at the pattern here, you do the same thing every single time. You multiply the number of roses by 0.75, and then you add 20. And so therefore, you should be able to say, okay, well, let's just take 0.75, multiply by however many roses there are, and then add 20. All right, so let's go on to the cost at Flower Power. All right, so we will go ahead, and for 10 roses at Flower Power, we've got to pay 60. That's the down payment. Now, it's 50 cents per rose. So it's 50 cents for 10 roses. So to get that, I'm just going to take 0.50 and multiply by 10. And so that should then give me $65, which is significantly more expensive than Roses Are Red. All right, so let's go ahead. We'll go to the next one. Again, I'm going to fill these out really quickly so that we have the numbers that we need. So now we got all these things filled out. We can go ahead and do our equation now. Similar to before, you notice that we do exactly the same thing every time for the given x value. So we got 0.50n plus 60. All right, so therefore we are ready to move on. So it asks us to write the function rule. We've done that. There's the Roses Are Red. Doot. There's the Flower Power. Boop. Okay, we're ready to go on to question number 3. What patterns do you observe from the table of values? Well, you could name any number of things. I'm not going to write it down because these pens are annoying. But you notice, let's see, if we're looking at the table, well, I notice that every single time for Roses Are Red, I'm going to add 20. I notice that every single time I'm going to take the number of roses and multiply by 75 cents, right? For Flower Power, I notice I'm going to add 60 every time and multiply by 50 cents times the number of roses. These are very simple patterns. Another pattern is that they're getting closer and closer together, right? Right here, they're $35 apart. Here, here at 35 and 70, they're $35 apart. Here, they're $25 apart. Here, they're only $2.50 apart, right? So they're getting closer and closer together, and then at some point they cross, and now Roses Are Red is more expensive. It's $5 more expensive. Now it's $12.50 more expensive. Now it's $210 more expensive. So you can see that it's a very consistent change, but they're getting closer and closer until at some point they cross, and then Flower Power just keeps getting cheaper and cheaper than Roses Are Red. All right, so now we look at number 4. What happens to the cost of roses as the number of roses purchased increases? Well, obviously the costs increase. It increase at a linear rate. You should recognize this function right here as being a linear function. There's no squared, so it's no quadratic. There's no exponent, so it can't be exponential. And it's not an absolute value, so it can't be that either. So out of everything that we've studied, that's the only one that makes sense, is that it is a linear, right? We talked about the number in front of the variable being the slope, and we talked about this as being the y-intercept. Okay, and so you've got a lot of details here that kind of point towards this being a linear equation. You'll notice that the 0.75 is a bigger slope than the 0.5, which is why this is a little bit steeper. It gets a little bit more expensive as you get farther on. Number 5, how many roses can you buy from Roses Are Red for $65? So now we're going to take this and we're going to plug it into our equation. We're going to go 65 equals, then the Roses Are Red equation was 0.75. Actually, we probably don't even need to do this because I think that's one of the ones on the chart, right? So there we go. That's how you would set it up. You could work that out, but it looks like for 65 I can buy 60 roses. Now for Flower Power, let's see, 65, Flower Power, yeah, there it is. It's on the chart. Flower Power, I could buy 10 roses. Okay, so we actually don't even really have to do any algebra yet. We just read that straight off of the chart. Is there a point where the two flower dealers charge the same amount? And we already said that. Yes, they cross at some point in time, right? It says, what is the charge? Well, we can't really tell that exactly yet. If you pulled it up on your calculator, you might be able to arrow down and go down in a table, and I can show you that later. But here we just say, okay, well, yeah, it looks like here Roses Are Red is cheaper, and there Flower Power is cheaper. So I'm going to guess that somewhere around 155, maybe 160 roses. So we'll just say between 125, that's not 155 to 160, somewhere in there. Okay, now I'm going to pause this and pull up my calculator. So let me show you how you would do this on your calculator. Now I'm going to do it on a TI-84, which is right here, but you can do it on an 89 or whatever other calculator you have. So you need to go into the y equals screen. Okay, sometimes on an 89 you can get there from the home screen. You can just kind of arrow around till you get the y equals. Otherwise, there's generally a button that allows you to type in the equation. So for the first one, I'm going to put the Roses Are Red, which was 0.75 times the number of roses plus 60. All right. Sorry, that was 20, wasn't it? So let me go up here and change it to 20. Okay, and then you push enter, and then we're going to go 0.50 times the number of flowers plus 60. Now the nice thing about this is you can actually make a table. You can see the table right here. At 89 should have a similar thing. So I'm going to go second to get the blue, and then table. Now I can do a table. And so if I go down, you can get different values, right? You can see, okay, for 25 roses, it will cost me $38.75 with the Roses Are Red and $72.50. At any point, you can type in, if you want to get to a higher number. But for example, we said we thought the prices would cross somewhere between 155 and 160. So we're going to go to table set. So we're going to go second, and then table set is this blue one right here. So there we go, and we want to start at about 155. Okay, and then we will go enter so that it saves it, and then we'll go back to our table. And so from here now I'm at 155. You'll notice this is 150. That's one of the values that you had to calculate for your table up above. Now I'm going to go down. Let's see. Roses are red is still cheaper. Roses are red is still cheaper. Roses are red is still cheaper until I find the place right there where they're equal. So it looks like right at 160, they costed me exactly the same amount. Pretty cool, huh? All right, so let's go ahead and look at this. So from the table, can you tell which company offers the better deal? Well, it depends on how many roses you want, right? If you want only a few, then obviously you're going to go with roses are red. If you want more roses, then you're going to need to go with flower power. Okay? Again, that's completely up to you. It probably depends on the size of your school. If you have a very large school, then you're probably going to want to you go with flower power because you're going to sell a lot more flowers. But if you have a small school, chances are you're going to go with roses are red. All right, write an equation that represents the point where the two flower shops charge the same amount. Okay, so I need the cost for roses are red. The cost for roses are red was 0.75 n plus 20. And I want that to be equal to the charge for flower power. And the charge for flower power was 0.50 n plus 60. Now, it doesn't actually ask us to solve it at this point, but you could, right? You could subtract the 20 and subtract the 0.50, which would end up giving you 0.25 n equals 40. Because I subtracted 20, which would give me 40. I subtracted 0.5, which would give me 0.25. And so once I have that, I can divide by the 0.25, and I get n equals 160, just like we saw on the calculator already. All right, now we're going to come down here, and it's going to ask us for some window stuff. Okay, now finding a window is a valuable skill, because what it does is it will allow you to decide what you need to include on your graph. It'll help you with your calculator. Here, let me show you. If we go to our calculator right now, and most of you know that there's a graph button. If I go push graph, then here's what I'm going to see. Oh, it's done thinking. I see nothing. Well, that's because the calculator goes from 0 to 10, generally speaking. So even if I get 0 roses, that's going to be way off my graph. So it's going to be important that you understand how to get some valid pieces for your window, and I'll show you then how we can use that on our calculator. So justifying our settings, so the minimum x value. Now remember, x is the number of roses that we buy. So I'm going to say the minimum is 0 because that's the least number of roses that I can buy. All right, now the maximum x, if we look up at our table went up to 1,000. But you know what? We already talked about the fact that the interesting place happens somewhere between 150 and 180, and we already calculated that in 2 different ways to be 160. But you know, I'm going to go ahead and go up to 210 just because I can see that, you know, that would at least give me a little bit of space after that. So I'm going to go and make my x value 210, and my reasoning for that is because the interesting point. I'm not going to write because PDFs are not very good at this. But the interesting point happens before that, right? So I can make sure if I go from 0 to 210, I include the least amount of roses, and I go up to the point where they've already crossed, and I know that flower power is going to be cheaper from then on. All right, so y min, you can put whatever you want. You could put 20 there if you wanted to, because that's the least that you actually have to pay. Remember, y is the output, which is the total cost. I'm going to go ahead and put 0 just because as long as I'm going all the way down to 20, I may as well include that last 20 so that I see both of my axes, the x and y axis. Okay, for y max, that's the maximum that I'll pay. Remember, I only went up to 210 with my x values, which means I really only need to go up to about 180 or 200. So I don't know how big my graph is yet, so I'm going to go ahead and say 200. But if I don't quite get to 200, that's not a big problem. Okay, so again, this is the range that would then fit the x values that I just put in. So now it asks me to sketch both functions. Now I already created my window. So on x, I want to go from 0 to 210. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it looks like I can go by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 200, okay? So I'll be able to fit my whole window in there. And then here, I'm going to go same thing. I think I can probably fit 10, 20, 30, 50, 60, 70, 80, 90, 100. So I'm just setting up my graph. 1, 2, 3, 4, 150. And it looks like I was just, that is a 5. Ay, ay, ay. And so I'll put 200 up here. So now I should be able to go through and put my points on. So I'm going to pause this while I put the points on from the table. I'm going to make 2 lines. One line is going to be for roses are red, and the other will be for flower power. All right, so there we go. I've labeled them so that you can see. I put a couple of the points on there. I've got the roses are red, and I've got the flower power. All right, so that's our graph, and you can see very clearly where they cross somewhere around here, which may or may not fit exactly what we talked about in our graph, but that should be pretty close to the right place. All right, so now I want to show you how the window is going to help us on the calculator. So let's pull out the calculator here. You may remember that we typed in our equations before. So there were the equations. Now we're going to go to window. Strangely enough, it's called the same thing, window. Now we're going to make our x-min 0. We're going to make our x-max 210. The scale, you can do whatever you want with that. Since it's 10 on my graph here, I'll go ahead and make it 10, but it doesn't really matter that much. The y minimum was 0, and the y maximum was 200. And, oops. The 2 didn't show up. Okay, and again, we'll go by 10. You don't have to worry about any of the other stuff here. Now, if I tell it to graph, you'll notice that it's changed my picture. It's going by tens now. It's actually going to give me this place where the 2 cross. Now, since I've done that, I'm going to go ahead and show you one more thing. The neat thing about these calculators is they will actually find that crossing point for you. You don't even have to look at the table and keep going until you find. You could have done this all from scratch if you had the equations, because you can go into calc. See, all this stuff up here at the top of the calculator, that's all dealing with the graph. And so we can go into calc, and it'll help us calculate from the graphs. We'll go second and then calc. We're trying to find the intersection. So we'll go to the intersection. Now it's going to ask for the first curve. So I'm on my first line right now. And then you'll see when I push enter, it jumps up to the other one. And so that's the second curve. You see down here at the bottom, it's asking a question, so you've got to do something. So I say yes. It asks for guess. You don't have to do that. You can if you want, but if I could just kind of arrow over here, there's about where they cross, and so I'll hit enter again, and then it gives me an intersection, which is at 160. And you'll note it also gives you the y value, the total cost at that point. The total cost is $140 at that point. They would both charge the same amount. All right, so let's go ahead and answer the last couple of questions. What effect does the 75 cents per stem cost have on the graph of the roses are red function? Well, it causes it to go up 75 cents for each rose. And so if it's going up 75 cents per rose, that's going to be the slope. Okay, what effect does the $20 have? Well, that's the starting point, right? If you look at your graph, the $20 is the y-intercept there. All right? Then the same questions for the flower power. What effect does the 0.5 stem have? Well, that's why it's not as steep, because you've got this going right here. And so the 0.5 is not as steep as the 0.75. You can see that that's the slope, right? And then the second question asked down there was, what did the 60 do? Well, that is your y-intercept, right? Because that's how much you pay even if you don't get any roses. That's the down payment. What are the coordinates of the point of intersection of the two functions? Well, we found it now in 3 different ways. We calculated it using our equation that we wrote on the 2 pages before. We looked at the table. we looked at the graph on the calculator, and we looked at our hand graph, which wasn't quite as nice, but it almost gave us the same thing. Now, we didn't get the 140 when we calculated it by ourselves. Okay, so I did want to look at that just really quick. It won't do that. Okay, there we go. So if I go up, you'll remember we calculated the 160 by hand here in number 9. Keep in mind, this doesn't actually ask you to do that. We just did it because we know how to do that. Okay, but if once I get that I have 160 roses, I do need to plug that into one equation or the other to get the total cost, right, for this last part. So you could do that. It doesn't matter which one you put it in because we already said it costs the same amount there. Now the last question is, which flower dealer offers the better deal? Again, this is the same question that's been asked 2 times before, and it's really up to you to decide. It depends on how many roses you want and etc. So I am signing off because this is plenty long enough. Ciao.